Good afternoon. It's my job to perhaps lull you to sleep before just before the afternoon tea session. Phil Ransom. I'm currently the head of track and survey for SNC-Lavalin. I'm based here in Manchester. I'm going to tell you a little bit about that in a moment. What I'm going to try and cover in my presentation is just to look at some of the lessons we've learned in delivering certain projects, design projects and survey projects over the last year or 18 months or so, and hopefully bring those to the fore and perhaps reinforce some of the messages we've heard from the previous presentations. And in fact, in one instance, my thunder has been stolen slightly, but you'll see that in a moment. And for me today actually is quite an unusual day, because most days if you said to me, in fact those days if you said to me what you were doing yesterday, I'd probably struggle to remember. And it's certainly if you said to me what were you doing a year ago, I wouldn't have a clue. But today I know exactly what I was doing a year ago at about this time. Now, I guess most of you don't, but about a year ago I was actually in the final approaches to landing in Heathrow on my way back from Australia, because I've been working out there for 4 years, and it just so happens this is the anniversary of that said day. Anyway, it's very nice to be back. Okay. I need to press the old button. I mentioned that I work for SNC-Lavalin, and I guess SNC-Lavalin is a name not particularly well known by most of you. I just would like to, if you'd indulge me for a moment or two, I'll just give you a few slides about SNC-Lavalin. SNC-Lavalin bought Interfleet, who I've been working for since 2010, back in 2011. And we've just actually changed our name, so the Interfleet name is no longer, and we are now part of SNC-Lavalin, and we trade as SNC-Lavalin. And I work within the infrastructure team in rail and transit. Mentioning that, it gave me the opportunity to slow this slide. If nothing else, it's a very pretty slide. And this is one of the projects that SNC-Lavalin are particularly proud of. They're principally a Canadian-based company, although they work globally. And this is some pictures of the airport line in Vancouver, and it opened in 2010. And it's just an extremely nice picture, so I thought we'll put it up there. But it's a great example of the kind of work we like doing. In particular, this is an end-to-end project. So this is a kind of a finance, design or engineer, build and construct, and in fact operate and maintain. So I guess the reason I raised that is because I'm going to go on and talk about the entire asset life cycle when one's looking at a project. And here's an example of an end-to-end project for real. Okay, rail and transit engineering, as I mentioned, we're a global business, and the principal reason for putting this slide up is, as well as mentioning that we cover all those aspects of design and consultancy and major projects, etc., is to get the words back up there about complete railway life cycle, and to tell you some of my experiences now leading and working with the team here in Manchester, looking at track and survey. These are the kind of disciplines we cover, and within there, in the centre of the circle, we've got the various railway types: the main line, the light rail, the freight, metro, etc., etc. And as I move on to the next slide, I'll perhaps elaborate on an example of a project in each of those categories. Okay, hopefully this is fairly visible to you guys, but I've tried to cram a lot onto to one slide here. In the light rail category, the project I chose to look at was some work we did here in Manchester on the Victoria Station tram interchange and the track alignments for that. In the main line category, a job again close to home, Frederick Road. This is a track lowering scheme where we had to undertake the survey, the track and drainage design, and there's quite a few lessons came out of that, and in fact some shared lessons with what we've heard that's going on the Great Western route at the moment, for example, and all the problems of formation and drainage and formation and drainage and formation and drainage. In terms of freight, interesting little job we did at ARCO, which was to provide a new connection to the West Coast main line, and to put in some new sidings for the quarry operation there. And a reasonable amount of learning came from that experience, I must admit. We've even been working on some high speed. We've used technology to deliver a feasibility study to look at a branch line, effectively a high speed branch line potential connection to the HS2 proposed HS2 route. In the metro category, now this is where the Australian connection comes in. There's another job in Victoria, but this one's Victoria, Australia, as opposed to Victoria, Manchester. And here we were looking at some grade separation works and feasibility studies, and I'll elaborate a bit on that in a moment, but a job I was involved in from the other side of the world, as it happens. And I had to try and think of something to put in other disciplines, but what I've picked is the work we've done on the West Coast Main Line power upgrade, and the use of advanced survey techniques to allow us to see where the overhead line equipment is. And we just saw a really good example of that as well with the Stafford Alliance, and trying to work out where a gantry is relative to the overhead line wires. But the same technology and the same techniques are used in the initial design and the design of overhead line upgrades. Okay. Those of you who've heard me speak before, you know I've a passion for asset management and asset life and all these kind of words. You've heard these from me before. Here's yet another manifestation of a rail asset life cycle. And the thing to focus on is in this instance is the words around the outside, and the fact that any asset is probably, unless it's a completely new asset, it's in some kind of form currently being operated and maintained, the current railway, for example. And then as one moves around the asset life cycle, one's looking at what are we actually going to do with this asset, what's our strategy for it, the procurement process, the engineering or the design, the construction that's undertaken to undertake whatever change or alteration to said asset. But the important point is it comes back at some stage into operations and maintenance, and I think as designers we must never lose sight of the fact that what we're designing actually has got to serve a purpose and ultimately become an asset that provides the railway, and then has to be operated and maintained. This is kind of a different manifestation of the same thing. So this is more of a linear model. What I'm trying to show here is I guess it's the same thing to some extent. This is the grip processes, so 1, 2, 3, 4, 5, 6, 7, 8. And it's worth remembering there are 8 stages in the grip process, not the sort of 2, 3 or 4 that we tend to focus on most of our lives. Sitting there in the middle is a detailed design. That's where we all get very excited. But there's quite a lot of work to do before you reach the detailed design phase. The construction bit's always very interesting, and lots to learn and get involved in. And then if we're not careful, there's the scheme handback and run away and leave the poor old operator and maintainer to his own devices for ad infinitum. So I'm also showing overlaid on here a sort of a grip stage -1 and a grip stage 8+, which again is the concept that said asset or said project is there to deliver something that actually goes back into operations and maintenance. So these are some of the findings from the kind of study and looking at the particular projects that we selected. So if we look at perhaps the early stages of any project, we're in the concept, the feasibility. We're looking at trying to define the output of said project. So that's the desired outcome. Actually, is the definition of the project. This is where we desperately need information to enable this process to be undertaken, to actually undertake this analysis. And the more information that can be made available at this stage, the better. So this is where all of those record drawings and the lost files and the knowledge of the asset, the current asset, are so vital, and having a quick and easy means of pulling that together is essential. I think the Frederick Road example was a good one. That the slurried, sorry, not Frederick Road, the tunnel example with the slurried patch or length in there that wasn't foreseen, but actually there was records, there is information available to tell you that you might encounter that issue. So yes, gaining information important. Something I feel very passionate about. This is where you really have got to get engagement from the asset manager and the operational professionals within the railway. Those who are responsible for this asset. And this is always difficult. You know, I've been in an asset management role. I'm sure lots of you have. You've got a day job, and the last thing you really want to worry about is that job that's going to be happening in 2-3 years' time. But unless you devote the time and energy to giving that input at that stage, the ultimate outcome will not be perhaps what you would like to see or hope for. Obviously, there are numerous stakeholders in any project, so get them together, get their information, and get that downloaded. Invest in site investigation, invest in ground investigations, invest in whatever survey requirements you need at that stage. Often not a popular decision to spend money up front at such an early stage in a project, but again, if you haven't got the records and information available, do get that information and use it in your deliberations as you start to define what you're trying to achieve. I've mentioned the drawings. It's often the case that adjacent projects or adjacent works can feed quite useful data into the process. Now's the time also to start thinking about risk. You know, what are the risks that might be encountered as you go forward? And it does no harm to start the risk register at this time. And another key issue, again, we've heard mention of this today. Ultimately, you've got to deliver this, and you've got to seek approval and certification for said project. So be mindful of the regulations you're working under, the current standards, etc. And be very conscious of the fact that part of the definition is that you've got to achieve the appropriate standards for approval. So the key message really is to devote time and energy and resource to defining the project requirement specification. And that project specification has to be informed and agreed, and I've underlined those two words. So with all the information available to the team putting this together, and with the agreement of the stakeholders. And I'll probably say this again, but don't be tempted to try and put these things off to later in the project cycle, because inevitably that thereby leads a road to perhaps rack and ruin. So you try and address these issues early on and up front. An example of a job which I mentioned before, this is the potential Stoke alignment branch from the HS2, a feasibility study we undertook. We were able to do this using readily available data, survey data, OS mapping data, Google Earth data, etc. Easily available data actually these days. And very impressively, in my view, one's able to come up with some quite detailed options and alignment options, enough certainly for people to assess that option and to decide if this is what needs to be required or not, and to firm up on the specification. Certainly adequate accuracy to undertake any planning or engineering feasibility study. So it's a good example of the technology that's available to all of us at the moment, or currently, to undertake a feasibility study, and then ultimately to feed that into an output definition if the project is decided to proceed. We then move into where we're trying to firm up, and we're trying to actually detail the feasibility and select the appropriate option. So working the options up into in more detail. Important that one starts to consider here not only the first cost, the cost of undertaking the work, but starting to consider the whole life cost. And we've heard that mentioned. We've also heard safety cost model mentioned today, which another way of assessing the economics of a potential project. Very important that you have a strong design management process for the project so that you can start to really nail down the deliverables and get those things delivered on time. Yet again, any delay or failure to provide the right information at that time can be pretty fundamentally poor and affect the outcome. You need competent people, and I'm going to come to that in a moment. How do we ensure we've got competent people to deliver these kind of works? You're going to see the word collaboration on more than one side. Very important, I think, that each part, the various parties work together to a common end in a collaborative way. And confrontation in this instance doesn't help at all. It's all about having shared and agreed goals. Starting to add more detail and develop this design risk assessment as you work through the process. One of the key lessons for us is in terms of delays to the process. If you've got something to approve or look at or turn round, it needs to be turned round in the prescribed time. If you build an extra day or two in here, it just has a knock-on effect all the way down the chain. In the ultimate, it might even end up in an overrun or something, and 2 or 3 years downstream. But very difficult for people to actually make that linkage. But in practice, that's true. This is the stage as well where you need early contractor engagement. You need to start thinking about the construction aspects of any project and get that input to the design. So that you're actually designing something that's and starting to develop options, but that are buildable, constructible, or whichever word you wish to use. Another lesson learned, perhaps, is the whole concept of excuse me, is access planning. As we know within the rail industry, one has to plan one's access months or even years in advance. It's very, very difficult to do, and the only way you can actually do that successfully is if you've got a good idea of what it is you're actually trying to build in the first place. All too often we hear the fact that a project has been developed and evolved and it's matching into an agreed access program, and the access program isn't actually suitable for what's trying to be built. Again, we heard that, I think, at Farnworth, those words or similar words we used there. It's an easy trap to fall into, but the reality is you need to have a clear view as to what you're trying to achieve. And I mentioned the use of technology. I mean, as you can work out, I've been at this for a while, so I'm still on a daily basis blown away by the technology that some of the guys I work with just use as a norm. But the example we saw of using the drone, for example, to capture data on the Stafford Alliance, a massively good use of technology, and something that probably 2 or 3 years ago we wouldn't have even perhaps considered. I've jumped back to Victoria, and this was the Australian Victoria job. It just happens when I was working down there, we had the opportunity to deliver a feasibility design for the V-line in Victoria and the government there. And that work was actually conducted by our team here in Manchester. And we were passing information backwards and forwards, but we were able to work with sufficient detail from things like Google Earth to provide that study successfully. And that's a good example of kind of global working and working with remote teams, which is something a lot of us talk about. Actually putting it in practice is a little bit more difficult, but one of the key messages there is to ensure that you've got a good relationship. You know the people you're working with, you've established a relationship, and they understand the kind of standards that you're trying to work to, and it's worth investing time and effort into delivering that. I'm going to have to skate on a little bit, so I'm running on. Here's the single option developing, and again, this is about involving the other disciplines, keeping people informed. Looking at value add and cost savings, trying to find efficiencies in the construction methodologies. Again, the strong project management. Again, the collaborative approach. The example I've used here, and this is where I had my thunder stolen. I was going to use the same quote from Chris. I worked with Chris when I was in Network Rail to help develop the standards for surveying. And I remember him saying this survey once used many times, and it's copyright Chris Preston, but it's already been used once today. But if you can establish the survey grid early on, and you can start to use the various information, LiDAR or whatever, you know, that information can be used and taken forward into the other phases of a project, the actual final design, the construction, and even into operations and maintenance. And the West Coast route upgrade is a great example of that, where the through alignment design is now used routinely to maintain the railway. I should flick over these slides, but these are just some slides showing the various technologies of you know, LiDAR survey by air, and effectively homing in, but being able to gather more and more detail in the 3D model is sufficient to develop the design, and then ultimately in the bottom right hand corner there to produce the 3D manifestation of the proposed design alignment. So more and on. If you want to come and talk about that, come and have a chat on our stand, and we'll tell you more about those kind of technologies. I've got 60 seconds now, apparently. The design needs to be compliant. We need to look at the any non-compliance. Pragmatic engineering. I had the pleasure of reading through and being one of the judges on the papers competition that goes alongside this this conference, and one of the things that really shone through there was the use of pragmatic engineering, and not just slavishly trying to follow standards, but to apply some engineering judgment. And in fact, the winning paper was a glowing example of that. Construction and buildability, etc., etc. I'm just going to quickly mention safety. Here's a job we're doing currently at McGaul, a new station design. And I'm just really taken by the idea of starting to build in the information about risks into the design. And that ultimately is being used by the contracting organisations as they deliver to communicate and convey the potential risks and hazards to the people who are undertaking the work. And ultimately that information can transfer into maintenance. So we are the construction phase, and the key message here is about trying to learn and transfer knowledge. We have the challenge, I think, as managers and leaders in the railway industry currently. If we're not careful, we can all work in silos. The designer's the designer, the constructor's the constructor, the maintainer's the maintainer. And if we're not careful, it's not people in those various areas don't get the opportunity to understand what's required when one's undertaking the construction, and what's a good design, what's a bad design from that point of view. So we need to find strategies to ensure that people can gain that knowledge by perhaps putting them out on site when the job is being constructed, or inviting the construction guys into the design reviews at that stage. And of course, another great mechanism for that is this institution itself. This is all about sharing knowledge, and please take that opportunity. And ultimately, the aim is to complete said project and get it back into operations and maintenance. Not just throw it over the wall and run away, but make sure that the data and is available and passed on, and the asset management systems, etc., are updated. And also spend some time doing what we've done on these projects. Review what you've learned, take that learning and disseminate that, try and embed it into your future work, and try and share it through whatever means. So there we are, back at the asset life cycle. We start with operations and maintenance, we've run through the process, and we've popped out the other side with a lovely asset that's fully operable and maintainable. There's no rocket science in any of this. it's all about just thinking these things through, working together in a collaborative way, and trying to address these challenges that I talked about of how do we share knowledge across all of the aspects, all of the boundaries of the asset life cycle and the project life cycle. And I have overrun, I do apologise, but thank you very much for your time.